The setup of example 7 is going to give us a few built-in shortcuts, and we'll see that as we go. Converting our system of equations into an augmented matrix will give us our first row as 1, -1, and since we're missing a z term, we'll drop in that placeholder 0. In equation 2, we'll have a missing y term, so we'll drop in that placeholder 0. And then in equation 3, we'll have a missing x term, so again, drop in that placeholder of 0. Our initial goal is to get row 1, column 1 to be equal to 1. In this case, again, that's taken care of for us. So now what we'll look at doing is zeroing out all of the values below that 1. We have the advantage that that x term is missing from our third equation, so that work is already done for us. What we will need to do, though, is update row 2 by taking -5 times row 1 and adding all of those results to our values in row 2. So our values in rows 1 and 3 will remain unchanged, but then applying those row operations to row 2 will give us 0, 5, -7, and then 10. Our next goal will be to turn row 2, column 2 into a 1. So to do that, we can take 1/5 times all of our values in row 2, the 0 in that first column will remain unchanged, but then we'll get 1, -7/5, and 2. So it is possible that we'll end up with some fractions or other values that don't look quite so nice here, but we'll continue working with them because we are on the right track. And our next step will be to zero out all values below that 1 we just created. In order to do that, we'll take row 3, or we'll update row 3 by taking -5 times our values in row 2 and adding those to row 3. So the 0 at the beginning of that third row will stay unchanged. Taking -5 times the 1 that we have in row 2 and then adding that to 5 will give us a 0. And then what we'll do is take -5 times -7/5. So that will give us +7. Plus 4 will give us 11. And then 0. Now we have the goal of converting row 3, column 3 into a 1. In order to do that, we'll look at updating row 3 by multiplying by the reciprocal of that value again. So in this case, by 1/11. And looks like I dropped a negative there. That should be -7/5. This will give us that 1 that we're after, and then 0 divided by 11 will still just be 0. So looking at these as equations 1, 2, and 3, we can very quickly determine that z is going to be equal to 0 by translating this third row back to an equation. Row 2 will give us the equation y minus 7/5 times z, which now we know to be 0, is equal to 2, or simply y is equal to 2. And then equation 1 will give us x minus y, which is 2, plus 0 times z, which is 0, but is 0 anyway, is equal to 4, or x is equal to 6. So our ordered triple is the solution xyz, which in this case is equal to 6, 2, 0.